Hey students, this is lesson 121, slope. We're going to be learning about slope, and as you can see, slope has something to do with skiing, but as you're going to find out, it's got a lot to do with a whole lot more. What I'd like you to do is skip ahead to page right here, page 6. And here's a good little picture just to give us an idea about what slope is to begin with. This little caterpillar is going up a hill here, and the hill, we can describe the steepness of the hill as its slope. And to put some mathematical values to that, we can also describe that ratio as the rise over the run, where the rise is the vertical distance that the caterpillar is traveling, and the run is the horizontal distance that he's traveling. So if you look at this picture, you can see that if the caterpillar goes from that point to that point, it will be climbing 40 feet for the 100 feet that it will be going horizontally. And using those two numbers gives us the line's steepness, and we call that the line slope. So we can write that as a ratio 40 over 100, or we can simplify that to just 4/10 or 2/5. They're all the same. Okay, and if the line is a straight line, then that slope is constant over that whole distance. All right, we're going to go back to page 3 now and learn how to calculate that slope. Actually, go back to page 2. There we go. So here we have a line on a graph, and it has a slope, its steepness. And we can measure that slope between any 2 points on the line. We're given 2 points, S and R. Since we just found out that slope is the ratio of rise over run, what we can do is just find the rise between these 2 points by just counting vertically how far we're going. Since this is going by 2s, we're going up 2, 4, 6. So in this case, the rise is 6, and the run is the horizontal distance. And since this run goes by 1s, 1, 2, 3, the horizontal distance is 3, and then we can simplify that if possible, and the slope of this line is 2. Another way we can calculate that slope is just by using the points. So the coordinates of the point R, I'll put this down here, are 1 and 6. The coordinates of S are 4 and 12. And we can also find that rise and run by using points. The Y coordinates, so these are the X coordinates, these are the Y coordinates. The Y coordinates control the vertical distance. So from 6 to 12 is how far we're rising. Well, that distance is just the difference between those. So if I just take 12 minus 6, I get this number 6. And if I want the horizontal distance, I just look at the difference between the X coordinates here, 4 and 1. If I take 4 minus 1, I get this difference, 3. So if you're given 2 points on a line, you can just calculate that by subtracting the X coordinates, subtracting the Y coordinates. So, and that slope is constant. It wouldn't matter which points I use to find that. I could take these 2 points here also. So, and those 2 points I would have, let's call this point A and this point B. Point A is 2, 8. Point B is 3, 10. Again, if I subtract the Y coordinates, I'm going to subtract these 2. I would do 10 minus 8, which is 2. Subtracting the X coordinates, I do 3 minus 2, which is 1. And 2 over 1 is also equal to 2. So it doesn't matter which point you use, since that slope is constant over that whole line. All right, let's summarize what we've learned about finding slope on the next page, page 3. Down at the bottom of here, it says generalize on finding the slope of the line on a coordinate grid using 2 points for that line. Use the points x sub 1, y sub 1, and x sub 2, y sub 2. So you notice that to find the slope is the ratio of the rise over run. But you'll notice that I found the rise by subtracting the y coordinates. So in our formula, we'll just say y sub 2 minus y sub 1 to get that rise. That's these two. And then we'll subtract the x coordinates to get the run. That's these two. And it doesn't really matter which order that. You could do y sub 1 minus y sub 2 and x sub 1 minus x sub 2. But that's a generalized formula. So let's go ahead and put that into work here. The slope of the line through these 2 points on this. So this is, we'll call this x sub 1, this y sub 1, this x sub 2, and this y sub 2. And then using this formula here, we need our y coordinates. So we're going to take 89 minus 45. And then we need our x coordinates. So we're going to take 65 minus negative 23. Then we're going to subtract those. And we get 44 for our rise. And then 65 minus negative 23. Remember that subtracting a negative is the same as adding, so we get 88. And then dividing those two gives us 1/2 or 0.5, if you will. All right, so you can use these notes anytime you need a review on finding slope. And go ahead and if you want for tomorrow, just to get ready, go ahead and try a slope problem like that one on page 3. You could try and do the slope for, actually let's go to page 2 and do the slope on, maybe find the slope right here between these 2 points. All right, and I'll check back with you tomorrow.